morning and good afternoon, everyone. Thank you so much for joining us today. We're really excited to have you here for this LoRa Alliance pre-event webinar ahead of ACE 2026. My name is Chancey Sibley, and I'm with the LoRa Alliance marketing team. Before we get started, just a couple of quick housekeeping notes. This session is being recorded. We will share the details of where to find the recording in an email after the webinar concludes. Also, if you have any questions throughout the webinar, you can submit them using this QR code here. I've also included a link to the form, the link to that QR code in the resources section located at the bottom of your screen. Please be as specific as possible whenever submitting your questions so we can get the right expert to reach out to you. For anyone who may not be familiar with LoRa Alliance, we're a global association supporting the open LoRaWAN standard, which is used for IoT applications all over the world. Our members include network operators, device makers, solution providers, and many other companies working across industries like utilities, smart cities, agriculture, and industrial IoT, and many more. We'd like to welcome our new members who are listed on the right-hand side and also recognize Itron for upgrading their membership to sponsor level, furthering their influence over the LoRaWAN standard and maximizing their brand visibility. And if you'll be attending ACE this year, I also want to quickly mention our educational session taking place on Wednesday, June 24th from 10:15 to 11:45 a.m. The session is called LoRaWAN in Action, Transforming Smart Water Management Across North America, and it'll cover the basics of LoRaWAN, UI-1203, and share real-world smart water use cases from across North America. If you're interested in attending, you can register by going to the ACE website. And if you're already planning on attending, you can find it in the ACE agenda under the session WED060 and add it directly to your conference schedule through the ACE event website. You can find the LoRa Alliance along with other LoRa Alliance members in the ZENNER booth, which will be located in Hall B, and they'll have a variety of games with opportunities to win prizes, so make sure to stop by. Today's webinar will be about interoperability and smart water metering with a focus on the UI-1203 Sensus protocol. And with that, I'm very happy to introduce today's moderator, Remy Demerlet, who is the chair of the LoRa Alliance Smart Water and Energies Working Group. Remy has been heavily involved in the utility space and brings a lot of great real-world insight into LoRaWAN deployments and adoption. He will now introduce today's speakers and give a brief overview of the LoRaWAN ecosystem. Remy, thank you for being here. I'll go ahead and hand it over to you.
So today is our webinar about UI-1203 protocol over LoRaWAN. I'm very pleased to welcome our webinar speakers with Ralph Stillinger from ZENNER USA, Eric Bourbeau from X-Telia, operator in Quebec, and Jonas Papiolinis from Mainlink, a network service provider. We have in the next slide an overview of what is a LoRaWAN architecture and what is the, let's say, ecosystem. We support through the specifications of LoRaWAN that are made by LoRa Alliance, an open network protocol called LoRaWAN. LoRaWAN stands for Wide Area Network using LoRa Radio. LoRa radio made by Semtech allows long range and low power transmissions. So it's a very efficient, especially for the case of smart water meter devices that need to last with battery for a long time and communicate from harsh environments such as deep indoor, for example, in water pits. In the architecture, as we see, the device, the gateway, and the network server are the necessary components to build and deploy a network of any size. You can have multiple gateways, but you have only one network server. It's a star network. It's very well designed for optimizing the consumption of the battery with a key feature of LoRaWAN called adaptive data rate. With also the different elements that are combining, for example, for security management of the network session key and the application session key that are hosted in a joint server. Or we have also the possibility to create roaming between networks, which are illustrated in this slide on the right side. What is essential to understand is the device will send the uplink collected by the gateways, transferred by internet link to the core central network server. And then the secured payload is sent to the application server, where only the application server can decode the content of the payload. It's a security to ensure confidentiality as well as integrity of the message communicated from the end device. So from end to end, LoRaWAN ensures security of transmissions. The ecosystem includes device, gateway, networks, and also solution providers and system integrators. So it's an open architecture. That's one of the key pillars. In the next slide, we will see the benefit of having an open protocol. We can ensure different flexible business models based on different network models. You can have public network, private networks. You can also combine with community-based network like Helium in USA or in Europe, also the same industry. And we have also combination of private, public, or community with hybrid networks. Satellite connectivity is also possible, and device can transfer uplinks to satellite, and satellite will reshare with the base station on the ground. So these, we say, multiple network models offer different business models. And the third pillar that we want to insist for success of smart metering deployment in the next slide is about how you can use standardization. Why standardization is important? There are multiple reasons. First is to ensure the best access to deployments, but also to the market, multiple choice of solutions that can work together, meaning interoperability of devices is extremely valuable for these investment made by utilities or by companies because they can secure different suppliers, different source of components, gateway, device, or eventually also have different LNS. Also, open ecosystem with standardization allows to clarify how to collaborate, how to make easier integration of multiple different devices on the same network. The total benefit for the utilities from an investment viewpoint is a lower cost of integration, more choice of solution vendors make possible to optimize the cost effectiveness. In total, we see in Europe adoption of LoRaWAN because we support OMS and DLMS, It's also now a fact DNMS is going to be used for water metering, for gas metering, in addition of electricity metering. So this expansion is proving the standardization is getting more and more successful. In North America, we see that the water utilities are commonly requiring support of UI-1203 protocol made by Sensus. What is this protocol? How do we implement on meter interface unit? That's the topic that ZENNER is going to explain in this webinar. Next slide.
Thank you, Remy, for the introduction. Much appreciated. So let's go ahead and move on to the next slide. ZENNER. What is ZENNER about? First of all, we have predominantly been utilizing our own mesh-based networks in 2018, and we started transitioning to LoRaWAN networks by 2019, 2020, 2021, and now we have a mature LoRaWAN terrestrial system that we use in our networks. ZENNER as a whole has more than 10 million endpoints that are propagated throughout the world globally. And what we are doing now this year in 2026 as part of our moving forward with an open architecture and open environment is going LoRaWAN over satellite. And that's a big win for us, and I believe it's a big win for the industry. In all these protocols, we use UI-1203 over that particular protocol, in this case, LoRaWAN. Next slide. So in North America, the UI-1203 Sensus protocol has been adopted by the AWWA, and it is being used predominantly throughout North America, even in some South American countries and Canada. Basically, what you have to describe the difference between North America and other solutions is there is a pulse solution that's available. That pulse solution only uses 2 wires, which basically it just reads a pulse, and that pulse then gets incremented, and that pulse gets accumulated and gives you the value of the meter read. The reason UI-1203 is so popular is because you can connect to a register, such as this ultrasonic meter you see here, and you can read the absolute value of the entire register immediately. And that's very handy because now all you have to do is connect your MIU, which is a meter interface unit, to your register, and you get the whole value. So it's an advantage in how to read meters over the pulse, which required the accumulator. Next slide. So basically on the top here, you'll have the meter or the register interface using UI-1203, and the 1203 comes in. We read that through a microcontroller, and there is a UART, and in some cases there's bit-banged interfaces that you can drive as well to read that UI-1203. And then that data then gets transferred over to the LoRaWAN radio, and that on the top right, or the far right, middle right, I guess I should say, the LoRaWAN network then receives that data and deciphers that data. It's a fairly straightforward, easy interface, and that's one of the reasons that it's so predominant. Next slide. So next slide. Yeah, let's dig into this interface here with, excuse me, with the Alliance. What we have is we have many of our members and partners already using UI-1203 in North America. I've listed just a few of those in the top left rectangle that you can see there. And you can see where it's quite predominant, it's working, and it's growing actually quite quickly because of the LoRaWAN ability to transfer that data efficiently. Worldwide, there's MBUS, there's OMS, also there is UI-1203 in some South American countries, and you can see that worldwide there's more of a standard on M-Bus and OMS. So if you're going to propagate or build a network in North America, I recommend that you pick up this UI-1203 standard so that you can better address your customer needs. Okay, now I've left a link on this slide as well to take you to the LoRa Alliance marketplace that has all our devices. And just as a snapshot, you can kind of see those devices there in the middle of the screen. Okay, next slide. So with this slide, what I wanted to point out was LoRaWAN certified means that we've taken that particular device, the end device, and we've taken it through its tests and validated the fact that it passed all the tests and made it through to become a certified device. And the nice thing about this is once you have a LoRaWAN certified device, it plays well, like Remy mentioned earlier, in interoperability with different network servers, with different providers, and different gateways. And so what you have then, if you certify your device with LoRaWAN, you'll actually get a device that works well and in the environment that you're actually I want to say published, but that's not the right word. In the environment that you're actually installing it in. Okay, next item. So what does this give you, the UI-1203 Sensus protocol? Many of the vendors and registers already put out UI-1203 protocol. And so what we've done at ZENNER is we've built what we call a meter interface unit that reads the data from multiple vendor registers. So what we've done is we've joined the LoRa Alliance and becoming more open. And that means that you can take our MIU and read vendor X's data or vendor Y's data. So you get vendor neutrality because of the UI-1203. It does make it easy and more adaptive. And if you have part of your network that you wanted to replace, but you wanted to keep an older part of your network, you could keep that in play and save that cost savings of having to replace the entire network. And that's what the future proofing and investment protection is all about. So basically what we can do now is with this open architecture, going over LoRaWAN, reading UI-1203, you can expand and that's why the I guess the adoption of the UI-1203 enabled meters is now so high and doing really well. One of the things that we want to do here at ACE is actually show you about that. Okay, next slide. So digging into a little bit of the technical details here. It's synchronous communication. Yes, it's ASCII encoded, so you could bit bang it. You could get a UART. You could read it that way. It's over a 3-wire interface, TX, RX, and ground. Fairly straightforward. The spec right now goes to 8-digit reading resolution. I'll talk more about that a little bit later because we do have some registers that are over 9 digits. And then it collects real-time consumption monitoring. And it's compatible with different manufacturers, like I mentioned earlier. Next slide. So the way it started with UI-1203 was a fixed format. And you had X number of length. You have 4-character meter reading. It was quite constraining. And so what they did was they took this fixed format and they said, okay, now let's extend that. And the next slide will show you that the format that's used today predominantly in industry is a variable length format. And what's nice about this is you can embed certain codes in a variable length format and know that I'm working on, in this particular case, a US gallons reading of 1, 2, 3, 4, 5, 6. So it's quite representative and easy to read, and ASCII, because it's all ASCII based, makes it easy to decipher the unit and give the right reading to the customer. Next slide. A few more of the protocols here that I wanted to mention is we have this thing called the manufacturer field. And on the bottom right, you'll see that manufacturer field. And in that manufacturer field, each manufacturer can embed their own codes. And so that gives flexibility for different manufacturers. And if you happen to have their particular deciphering algorithm to read those codes, then you can use it. If not, you can just ignore the M field and move on and always read the RB field and the IB field. IB field being the serial number of the register, the RB field being the actual reading of the register, what the current usage is. Next slide. All right, a little more details here. I put this in for just a little bit of a technical deep dive, and I highlighted a few things, and we already discussed that with the manufacturer field. There are some errors in some of the protocol where you'll get an extra comma where you shouldn't have a comma. That does happen, and you'll have to account for that as you build your system. The protocol, sometimes you might think, okay, I expect it to be exactly like the protocol says. In some cases, you might have to account for some errors and handle that internally with your algorithm. So that's all we're pointing out here. Okay. Next slide. So how can I get started with UI-1203? Is it public? No, it's not public. It's a private Sensus protocol. You can contact Sensus, Xilinx, and they will, you'll have to sign a NDA and they will give you that protocol. But there is code out in the public GitHub that lets you get started with your Sensus protocol. And I've given you that link here. So you could go out there and search for that GitHub link and start a small Sensus protocol. It doesn't have all the error checking and all that, but it does actually do some of the reading and give you the value and the serial number. Okay. What's not public? Oh, that's okay. I'll just mention it here on this slide. What's not public is some of the manufacturers, they actually change the timing for when the bit pattern starts and bit pattern ends. So you'll have to watch out for that. The full command sets aren't always public in all the register definition modules. Complete pinouts for census meters and encoders are also not public, but you do end up with 3 wires, so that's standard. And the voltage level and signaling details for all configurations, some cases it's 5 volts, some cases it's 12 volts. Those types of things are also some of the roadblocks that you might run into that you have to overcome. Okay. So in summary here, the purpose here is to simply send meter readings in a generic format to an external device like a radio transmitter, which is our LoRaWAN module, and that works well. Its data format, again, just to recap, is ASCII based. It's been adopted by the American Waterworks Association, and it's very prevalent in the US. The functionality is the ability to read the reading, and the meter serial number is the basic functionality that is really supported throughout the industry and used a lot. The compatibility, there are some things that you can do in the UI-1203 format to let you connect to a meter and then do an auto detect functionality where you can change your timing and whatnot to accommodate for the different manufacturers. Okay. Next slide. All right. And this is my last slide on frequently asked questions. Are there any free license models? No, most companies test their readers against many manufacturers, so they'll buy meters from different manufacturers and make sure that their interfaces works with that manufacturer. Are there proprietary fields of data? Yes. As I mentioned earlier, there's a manufacturer-specific field that you can embed your data in for your specific register. Some people use pressure sensors. Some people use temperature sensors and put that data in their manufacturer field. How can we test and verify the compliance with the standard? This is a difficult question. The way that you do is you have to actually get different registers, test them out, and try them and see if your interface will work for them. And you'll find that there are a lot of similarities when you do your testing, so that gives you a little bit of an edge, and you can figure things out fairly easily. How do utilities require support of this protocol? in RFPs and tenders, it's mentioned as UI 1203 Sensus capable. That's one of the requirements that are in the tenders and the RFPs, and it's fairly rigid. They must have that. Okay. About other brands in North America, how do they differ from the standard? It's the timing issues and the manufacturer codes. And the reason they did that was some of the vendors wanted to increase their proprietary advantage. We believe at the LoRa Alliance, and also ZENNER has embraced this, to be more of an open architecture and give you the ability to pick the vendor that you pick that works well in your environment for your particular solution. Okay. Now, I guess the next slide is I'd like to introduce Eric Bourbeau, and he is from X-Telia. He's using these MIUs, and he's going to explain exactly how this works with his system. Eric?
Hi, everyone. My name is Eric Bourbeau. I'm president and co-founder of X-Telia. And I'm going to talk to you a bit about the standard, how UI-1203 compares to other options on the market for wireless reading of water meters. As well, I'll take a look at a use case to kind of give you a sense of how, in practice, it can be used and what the benefits are for the customer. First of all, who's X-Telia? Well, we are a public LoRaWAN network operator. We've been doing LoRaWAN for 10 years now, and we have our network is mostly in Canada. We also develop, build, operate end-to-end solutions, mostly in the municipal space. So municipal telemetry a lot for water. And our flagship product is XO or AMI platform, next generation AMI platform that works with cellular or mainly LoRaWAN communication. And of course, takes advantage of the UI-1203 standard. So why UI-1203 matters for reading water meters? Well, a couple of things. Mainly, no vendor lock-in. It's an open standard, which means that if you read a water meter that has, if you have a water meter that has that interface, you can read it. And if your device, your meter interface unit, it comes with the decoder, you can access that data directly from the LoRa network without even having to go to some third party or vendor cloud or application. So with the decoder, there's no vendor lock-in. You can do what you want with the data. No retrofit, as long as your water meter isn't too old and it's in North America, most likely it's got a Sensus or UI-1203 interface, which means that any brand of MIU that can read that type of protocol can read those water meters and you wouldn't have to replace them. What's great about UI-1203 also is that, well, the alternative is Pulse, basically. So in Europe, they started doing this a long time ago. So they started with Pulse, and it's mostly Pulse reading in Europe. North America is a little more recent, and the standard that was developed here and that is now the standard is the Sensus or UI-1203, which is a more recent standard. And it's a little better in the sense that what it does is it essentially reads what's on the dial of the water meter. So it reads that number. Every time you want to know what the reading is, the MIU will ask the meter will give it that number, and the MIU fires off the number to the cloud or to the network. With Pulse, it's a little more complicated. All the water meter does is it sends a pulse to the MIU. So the pulse is counted by the MIU, and the MIU keeps track of how many pulses it has seen in the past since it last sent an update. So that's a number that's incrementing in the MIU. And then you need to convert that back to an amount of water. So for example, if one pulse is so many gallons or liters, then in your application, you can do a conversion and then figure out how much water. It's less direct than UI-1203 where you're just reading the meter. A lot simpler. And UI-1203 is a real good fit for LoRaWAN because LoRaWAN is great at sending small messages, small payloads. Because it's low bandwidth, And also it's low frequency, travels a very long way with a small message. So the readings you get from UI 1203 are very small messages. In spreading factor 9 or data rate 0, you could potentially send 24 hourly readings in one message. So obviously there's a lot, just enough room in there to pack in these really small messages from the water meter. So it's a perfect fit. And because it's like a universal language that all water meters that have that standard talk, well, any brand of MIU that talks UI 1203 can talk to any brand of water meter, which is great. Now let's look at how LoRaWAN and the decoder and UI 1203 stack up against proprietary AMI systems on the market. Well, first of all, it's a lot easier to mix and match devices and brands. If you're going with a proprietary system, typically you get 100% of everything from this one vendor. So you'll get the MIU, the radio, you'll get the communication portion, which can be proprietary wireless technology, so antennas that go in your city, and then these proprietary radios or MIUs that talk to those antennas, and then that goes to a proprietary software in the cloud or in a server somewhere, and you're basically fully locked into this one solution. If this vendor goes out of business or decides that they're no longer supporting your area, then you're kind of out of luck. With LoRaWAN, you've got an open standard. So basically, any manufacturer that makes an MIU, you can buy and you can install in your environment and use it. LoRaWAN's a standard, so they'll all work on a standard LoRa network. And if you have the decoder that comes along with that MIU that you buy, and manufacturers of hardware typically will provide that, that allows you to take that LoRa message and decode it. So basically extract the reading from the message without even having to go to some proprietary or third-party cloud. You can basically get the message right off the LoRa network. And if you wanted to, you can build your own software if you want, and then just access that reading because it's your data and it's open data once you've got the decoder. I'm not saying everybody's going to start building their own application, but at least if you have the possibility of taking your data somewhere else, eventually you're not locked in, which is a great thing. The installation is non-intrusive. Up north here in Canada, it's cold in winter, pipes freeze outdoors, so typically water meters are in basements. So that means that the MIU is usually right there next to the water meter in the basement. And because LoRaWAN is so good at going through concrete and reaching through obstacles, because it's got such low interference, or it's got high resistance to interference, I should say, and long range, you don't have to have the MIU outdoors. It can be in the basement right next to that water meter, and it will work really well. Most of the proprietary RF systems aren't necessarily as good at resisting to interference, don't necessarily have the same range. A lot of them need repeaters. You have a lot more hardware out there. Installation can be a lot more complicated as well. And if it's a proprietary RF system, typically somebody's got to pay for a license with FCC or with Industry Canada here in Canada, FCC in the US, and that of course brings up the cost. LoRaWAN is a license-free wireless technology, so you don't have to pay for spectrum or license. Because LoRaWAN also is very low power, you will get easily 20 plus years of battery life. Not necessarily the case with proprietary systems. Scalability is easy with LoRaWAN. If there's a neighborhood that you decide to deploy water meters in, let's say a new neighborhood that's being built and there's no coverage because before you didn't need to cover this, well, you just got to add another gateway in that neighborhood and boom, you've got coverage. So it's really easy to expand as your requirements grow. You can just keep deploying the network. Of course, if, for example, you're using cellular for your backhaul of your data, if there's an area where the coverage is weak or non-existent, well, you're pretty much screwed because typically wireless operators aren't going to build another tower just because your water meter is having a hard time. Finally, data ownership is important. If you've got the decoder, if you're using an open platform, well, you've got all the choice in the world. You can do what you want with your data. It's your data. You're not tied in like most proprietary AMI solutions. So let's look at how simple it is if you want to do a project like this. First, you got to figure out what are the water meters you've got already? How old are they? Do they have an interface? If so, are they still good? Because after so many years, for example, mechanical water meters, after 25, 30, 35 years, they start undercounting because the mobile parts in there become clogged up and then they're not counting the real amount of water. But let's say you've got your meters all ready to go. You install your gateways, you connect those MIUs, 5-10 minutes per connection, and then there you go. You've got data flowing in. It's that easy. So let's take a look at a use case, Quebec City. That's one of our customers up here in Canada. Right now, we're finishing the deployment of the LoRa network that we designed to cover Quebec City. We're going to be hooking up, well, we've started already to hook up about 8,800 commercial meters in businesses and factories and stuff like that. They're using our XO application we're using the ZENNER Stealth Reader as our LoRaWAN MIU of choice. Great product. It supports not only Sensus, so UI-1203, it can also read Neptune that has a slightly different version of that protocol. It can also read Pulse. So great solution, comes with a decoder so we can do what we want. We developed an application that uses that MIU. For Quebec City, we're actually doing a LoRaWAN network as a service. So they're not buying the network. We're providing it as a service. We designed it. We built it. We're operating it for the next 10 years. And they're just buying the MIUs and they're paying for a license of our AMI platform. Benefits are obvious. No cellular subscriptions, 20+ year battery life. In the case of Quebec City, we're sending 24 hourly readings every hour, which gives huge redundancy in the data. It's all open standards. It's all interoperable. We're bringing the data right into their IBM billing system. No vendor lock-in. Wonderful solution. Here's the UI of our XO platform. Alarms, you can see graphs, you can see everything that's going on, very proactive. You can receive text messages or emails if something's not right on the network. So great platform, available in French and English. Very popular up here in Canada. And I believe that's it for me. So I'll pass it on to Jonas for the rest.
Hello, my name is Jonas Propolianis. I am engineer at company Mainlink and lead the LoRa Alliance Network Capacity Task Force. Today I'll present how we've simplified meter data integration using the UI-1203 Sensus protocol, which is specific to the US market, combined with a stealth device and the key results this approach delivers. Let me start with a situation that's probably familiar to many utilities. Most utility environments didn't grow in a clean, standardized way. Over time, you end up with a mix of meter types, different vendors, different communication technologies, and a lot of legacy systems layered on top. Now the real issue isn't just having different devices, it's what happens every time you add a new one. Each new meter or vendor typically means a new integration, new API, a new data format, new logic to maintain. So instead of scaling easily, your IT team becomes a bottleneck. Deployments slow down, troubleshooting gets harder, and data ends up fragmented across the systems. In some cases, onboarding a new device type can take months, not because of hardware, but because of integration work. So the problem isn't just complexity, is that complexity directly slows down operations and limits how quickly you can act on your data. So the question becomes, how do you get out of the cycle? The idea here is actually very straightforward. Instead of integrating every meter separately, you introduce a single standard way to handle them all. In this case, standard is the UI-1203 protocol, combined with a stealth device as acting as a bridge. Think of it as a translator layer. Different meters speak their native language, and the stealth unit converts everything into one consistent format. Then, over LoRaWAN, all the data is delivered in a unified way to the main Hive platform. So, from the software side, you're no longer dealing with multiple vendors. Everything looks the same. That means you're onboard new devices much faster. You don't need to custom integration work every time. Maintenance becomes significantly easier, and you are not locked into specific vendors going forward. Instead of managing dozens of integrations, you're managing one. And once you remove that integration overhead, something important happens. You stop focusing on connecting devices and start focusing on actually using the data. With a unified setup, data from all meters is centralized and consistent. That opens the door for real-time visibility across your entire deployment. In our case, Mainlink's main Hive platform handles that layer, collecting data from devices like ZENNER Stealth over LoRaWAN and presenting it in a unified way. Now you can detect anomalies earlier, monitor consumption patterns, and respond faster to issues like leaks or unexpected usage. It also becomes much easier to integrate with billing systems or other platforms through APIs because the data is already standardized. And from an operations perspective, you are not just monitoring meters, you're monitoring the whole system, including connectivity and device health. Most importantly, when you deploy a new meters, you're not starting from scratch each time. The system is already designed to scale. So the real value here isn't just simplifying integration, it's enabling faster decisions, better visibility, and more efficient operation across the board.
To make this more concrete, here are a few real-world MEI deployments where this approach is already delivering results. What's important here is not each individual project, but the pattern across all of them. You can see this works across very different scales, from a few hundred meters to several thousand, and in different regions. In all cases, it's similar architecture. Ultrasonic meters, LoRaWAN connectivity, and Mainlink's data management platform. For example, in California, the Housing Authority avoided around $500,000 in capital investments and is saving around $17,000 monthly. In Mission Terrace deployment, leaks were detected within the first 2 months, which is exactly where the real operational value starts. And in Mexico, moving away from mechanical meters enabled accurate billing and early detection of low-flow events, reducing non-revenue water. And since all of these are built on LoRaWAN, it's worth highlighting that regardless of the environment, whether it's a dense housing community or city like Guanajuato with a challenging terrain, a well-designed LoRaWAN network consistently provides reliable coverage and connectivity. So whether the goal is cost reduction, operational efficiency, or better visibility, the outcome is the same: more control over the network and faster decision making. And this ties back to what we discussed earlier. By simplifying metering infrastructure and implementing the integrations required for each property, utilities gain full visibility into their metering systems through remote real-time data collection. This leads to lower operating costs, time savings, and more efficient operations.
Thank you, Jonas, for your part. That was very self-explaining and very good for, I would say, illustration of how operator can help to test and to propose connectivity network to support this protocol. Here now, it's time to wrap up. In next slide, I wanted to illustrate some real deployments using smart water meters certified by LoRa Alliance. Here it's an example in Florida where Netmore has delivered a network with more than 80 tower-mounted gateways to cover a large area. That's also a challenge in this area to create connectivity that can reach deep underground for connecting meters using antenna leads, using such MIU. There is also a large aspect of the project using, I would say, this approach of a multi-tiered gateway to cover the area, but also to enable capacity for more than the smart water meters. So the total capacity could be up to 16 million of connections. And as we have from the feedback from the customer, they are satisfied today with the existing solution. They have reduced numbers, consumption anomalies. They can faster execute, operate the water network, and resolve possible customer claims. The coverage is better than what Cellular was proposing in the area, and they will go for new use cases. In the second example, a smaller network deployment here in California, again with a public network supported by more than 20 gateways for 40,000 smart water meters. In this example, the solution has proven to reach a fast ROI. It's a cost-effective deployment, and they are elevating the use of the network for also other application for water, conserving water, also monitoring electrical usage equipment, and so on. The next, I would say, slide will now recap what are the requirements from utilities. And most of the utilities in North America, but also in other areas, are requiring the same. They need a meter reading. SLA or service level agreement are typical requirement in tenders. It's translated typically in 95% or more successful meter reading rate. To ensure this, the use of quality network with a contract, for example, for quality of service, can be a very good way to secure that you will have the redundancy in network infrastructure, and you will have also the good tactics to optimize network efficiency. For example, using adaptive data rate is also essential to ensure you can comply with the requirement for long battery lifetime. Because that second requirement, that is typically 20 years in North America, makes obvious the connectivity has to be optimized for low power communication. LoRaWAN Class A is exactly designed for that. LoRa was designed typically for solving that use case of smart water meter reading. There are other requirements, typically in terms of location. Deep indoor is essential. So when you have a network with deep indoor penetration, you can also support outdoor and other use cases, but that's the most challenging. We have also a requirement for density or scalability that translate into either extending the network infrastructure or using relay. It's something that is supported by the LoRaWAN protocol. And you can also think of augmenting coverage by use of non-terrestrial network in combination with terrestrial network. That last requirement of UI-1203 Sensus protocol support is something that is very specific to North American market, and that today, for being clear, with more than 6 available meter interface units, we are, I would say, in position to tell that LoRa Alliance, LoRaWAN are completely ready for matching these requirements. And in next slide, I want just to code to actions to finish with this webinar. If you have questions to the LoRa Alliance or LoRa Alliance speakers, or need more detail further this webinar, please scan this QR code to fill in a form where we will create a direct contact for you to answer your questions. If you're looking for a device, you can go directly to the public marketplace. And if you are interested in joining the LoRa Alliance to benefit from the marketing activities and technical knowledge, as well as from the certification scheme that is essential to create and to ensure interoperability, please join to this LoRa Alliance. Again, we will be in ACE in June 24. There will be a side session of LoRa Alliance where you could meet with us and engage perhaps with our different members. Thank you for your attention.